Hi, my name is Chris, Christopher Ortega. I am presenting my senior project here that I worked on with my partner, Christine Hauser. We had decided to create a game, so it was both a website with authorization authentication, and it also is actually a game as well. So I'll go over a little bit about how we put that together, um, and then uh, and then we'll go over kind of some of the design decisions and things like that. Me and Christine divided it up between each other since there was only two of us. We both had to take on quite a bit of roles, especially Christine. So she was handling a lot of the design and art side of things. So a lot of different assets, animations, a lot of the more time-consuming parts of the application, and then I handled more of the programming side. So I was pretty much on a lead developer role, as well as we both discussed game design decisions and architecture in terms of the website as well. So, and that was due to each of our backgrounds. Christine has a background with art and design. She's very, very good at it. And then I also have more of a background on the programming side of things. So I have built a few games in different game engines, but that's kind of how we tackled this together and divvied up all the responsibilities amongst ourselves. So the game is called Crimson Crush. So it's got a little bit of a theme to NMSU. It is a match three game, very similar to Candy Crush or any of those other match three games that you may have played, where basically the goal is to just match three of the same item. There are bonuses for matching more than three, but for the most part, the core function of the game is to find those matches. Now, different match three games have different ways of adding challenges for the player to make, for their core game loop. For instance, Candy Crush, I believe they have moves. So you get a limited number of moves. I don't know if you do in the beginning, but I know as you progress through their map, and that's another big part of their thing is they don't really have much of a story, but they do have a map, almost like a Candyland type of map that you have to progress through. Now, Candy Crush has been around for a long time, so they have tens of thousands of levels, and that's kind of how they add challenges and different things. At this point, they've developed extremely complex algorithms based on the tremendous amount of data that they have to be able to kind of fine tune how these challenges, keeps the player just challenged enough, ultimately, so the player will pay money. That's what Candy Crush does make. I think they say about $4 million every day. So, and that's just their main game. That's not including their other spin-off titles. So they know what they're doing for sure. So we went a little bit of a different route. We decided to make a match three game, but it is timed. So I'm a big fan of stuff like that in video games. As a challenge, it kind of adds a layer of like you're trying to rush, a little bit of excitement. Similar things you see in like casinos and stuff like that as well. So just little, I mean, it's not gambling, but the like tricks that they use to make it more of a rush, make it more exciting. So it's every level you only get 60 seconds, which I kind of feel from testing it may be a bit much. But it's pure RNG. That's what makes us different. While Candy Crush is not RNG, they, as I mentioned before, they use very complex algorithms they've been developing for a very long time, based on just the sheer massive volume of data they have on players. They're able to basically fine tune almost every player's experience. For instance, if you tend to be more okay with spending money, your experience on Candy Crush will be completely different than a player who refuses to spend money on a game ever, right? And so they try to monetize you in a different way. So what they do is they just, the amount of resources and data that they have is just insane. So I chose to go with a different route. Something that also has been proven to be exciting is true RNG. And you see that a lot with like Pokemon cards, of course, scratchers, true random games like roulette, for instance. So a lot of that stuff is it's different than like a blackjack or a poker. Other video games are a great example. A lot of video games, they use permutations, so they there is a level of prediction to it, or skill. Now, true RNG is a different story. I decided to go with that. Now, it's not entirely true RNG, because when the levels load, and we use an 8x8 grid with 5 different types of gems. So when the board first loads, I did program it to check for matches, pre-existing matches, and if they're there, it won't use that board. It'll immediately load a new one. But it is RNG though. I did not take the RNG out of it. So most of the time, it doesn't actually. I mean, if it does detect a match, I mean, it resets so fast you can't even, like, the player can't even notice it. Like, they literally can't see it. But that's the only time where it's not true RNG. Everything else is pure RNG. So you have levels that somebody fails on a ton, that another player might pass right away because they got maybe a match 5, which is I can't remember. I remember calculating it. It was like either it was like a 4 to 6% chance of getting it. It's really low. It's by far the rarest one, but you could get one just immediately. Now, to actually get the bonuses, the way and I'll show you a little bit. We'll test it later. To get the bonuses, the player actually has to make a movement. So if you, for instance, when you do a match 5, it's called an Aggie bomb, and there's an explosion from a bomb that pretty much clears the whole board. So you get quite a bit of points for that. But when the new board loads in, it'll clear any, like, if there happens to be a match 3, it'll start doing combos. You don't get bonus points for the combos. So for instance, if you clear the board with the Aggie bomb, and then a match 4 drops in, it just counts as just 4 blocks being destroyed, which is about 40 points. I believe it was 10 points per block. So you actually won't get the bonus points for that. You only get bonus points on special events for actually making a player movement. So that's how we kind of balance that out. But that's pretty much the gist of how the levels work. You level up, or you go through the levels, and then as you go through the levels, you have the 60-second timer, and then you have a score goal you have to get to. And so we didn't have time to do it for this is basically kind of like a 1.0 release. So there's still other features that, if we were to actually make this a real live game that we were going to put in production and try to sell to customers, there's the future features would be even more challenges, like Candy Crush has so many challenges now because they've been out for like 15 years. But like one of the challenges at level 11, the board turns from an 8x8 grid to a cross, so it makes it more challenging to get matches, and so. But that's how it is. So it's all RNG to see how players get through there, and then in later rounds it would be something. For instance, like you have to, instead of having you still have a 60-second timer. The timer is the big part of our game, but maybe you don't beat the level until you get like 4 matches of blue gems, right? Only blue gems, and there'll be like a counter there. I didn't get a chance to implement that. And I didn't get a chance to implement the ice blocks either. But that's kind of, but that would be like, if we were to keep going, that's exactly what it would be like. Here's our 1.0 release, and for our next like 1.1 update, that would be something that me and Christine would want to have, right away. Assuming there's no like hot fixes or things like that need to be handled. So that's kind of how that's just an idea of like different challenges every 10. The idea was every 10 levels to add something new. And that's pretty much how that works. So now we do have an aspect that we're using Next.js here. Now I am using localhost here, but for our final submission, we'll show you the link, which we're mobile friendly. So we're mobile first. That's why I have it in the developer tool here appearing as an iPhone. Let's do 14 Pro. So it's mobile first. So that was our intention. And you can check the link when you get a chance. Just click on it on your phone. It's a progressive, or not. It's not true PWA, but it's just a web application at this point. But that's what we have right here. So you do have to log in. So I'm gonna go through the registration process. Here is Christine. As you can tell, she got right off the bat. She destroyed my high score, but that was the testing account I made. So I'm gonna make basically a test 3. So we have test 3 at test.com. I'm gonna go through making a new account, and for the password, we'll just do something simple like test 123 is a terrible password in real life. And then we will sign in. Oops, I didn't click the sign up button. So there we go. And for the username, we'll just put test3. And once we register, everything's good to go there. It's telling me that my password sucks. And now we have this. So at any time, it does store it as a cookie. So anytime the player loads in from their same device, it'll recognize it. They have to actually sign out if they want to. I did put like I did what a lot of other applications do, where they give you a cookie, but it like lasts like a year. But if you were to transfer it from a different device, you would just sign in again, and then when you sign out, it deletes the cookie. So, but that's just kind of to make it easier on the player. And you see this done with almost every application these days, either with cookies or with offline first, like IndexedDB or something like that for mobile. So once you play the game, you'll go ahead, and we'll just go ahead and run through a quick demo here. Just for a moment. Okay, so the game will load in, and up here you have your score. By the time you see our final submission, I'm gonna adjust this. I'm actually using a flex display, but I forgot to type in the flex column, so that's why it's kind of weird. Normally it would just be the score at the top and then the other 3 right here, but it's mostly your score out of the target score, which in this case is 0 out of 1,000, the level you're on, and the amount of lives you have. So we do a life-based system, which is similar to Candy Crush as well. They have total lives. That's actually how they make their money, when you run out of lives. But you have that, you almost got to your personal best or past a level that's been giving you a tough time. That's how they make their money, is it's hey, $5 for a few extra lives. And in that moment, just like casinos do, in that moment you're not thinking, right, and you're just like, I just want this right now, and you'll spend that $5. But of course they don't do it in actual U.S. current or any currency. They do it in I forgot what the name of their virtual currency is, but you see this a lot in any type of freemium gaming. And then the time limit too. So it loads in on this canvas that I designed. So basically the actual website itself is a typical Next.js application, and the game is separate. It's basically its own component that's separate from everything. So that way, any issues with the site or with the authorization, authentication, anything like that, are worked on separately from the actual game itself. Now here, for a better experience, turn on the sound. I did that on purpose because we do have some sound stuff, some little funny stuff, and then tap to start. So another thing too is I messed up on the title screen here. By the time you're actually looking at the game, it'll all be fixed, but that's what we're looking at here. And here's a little thing on when you click on it, it tells you how to play. It's hard to see here, but on your phone you would be able to see this very easily. Just a little brief overview, but generally most people that are looking at Match 3 games already kind of have an idea of how it works. Now once it doesn't play anything yet, but once the user actually touches the screen, it will start the music. And look, we already have a match 5 right here, so you actually can see an Aggie Bomb. So I'm going to go ahead and click on it. And then as you can tell, the music starts to play. I'm going to go ahead and turn the music down a little bit. But the time limit's going. Now, right here is an Aggie Bomb. So there's the explosion. Actually, Christine animated that explosion. And the level's done. Actually, that one Aggie Bomb, see again, it's RNG. You could have 100 players playing that would not get that, and then somebody else has to get it. It's pure RNG. So we're already on level 2 here. Now, as we keep going, is our match 3 right here. And then you just keep going and matching. See, the combos are going up. I programmed it so every combo, the pitch gets a little bit higher from the sound. So let's see if we can get more matches. And then that's level 2. And then we'll keep going here. And this is pretty much how the game works. So, and then Christine actually hand drew all of these with the shading and everything. Very, very good artwork here. Here's a match 4. So we have little sound effects. It's really rare, but a double, which would be 2 or 3 side by side, and they have to be side by side. So like right here, here's a double right here actually.
Twins, Basil, twins.
And I just added a little Austin Powers sound effect there. So that's pretty much the gist of the game. Now, if this is a game that we're planning on putting in production live, I would definitely, me and Christine would have more plans to add a lot more particle effects, sound effects, things like that. But a lot of what we did this semester was just making sure everything works and getting the game logic to work to flow really well with the actual Next.js application itself. And the timer ran out, and now I've lost a life. But this is pretty much how the game would be. So we keep playing. I'm actually gonna go ahead and let the lives run out again. And while we're waiting for the lives to run out, I'm gonna mute the music here. Now, all the logic was written pretty much in different layers. So we have like a manager for the board. There's actually a lot of files making this work right now, and the primary what is making a lot of this happen is actually a game engine called Phaser. It was designed for web applications, and it was made a long time ago. So this is before, as you know, like most of the apps on your phone right now are not actually native apps anymore. A lot of them are either progressive web applications. They're usually PWAs or progressive web applications, or some other form of a web application, or some sort of compiler like React Native, Flutter. I mean, there's just really no need for a true native application anymore, unless it would be a very, very extenuating circumstance where, like for instance, maybe there's just ridiculous amount of regulations from the government or like military, right? Like, and even then, like I can't even imagine the scope of something like that. And how many different parameters there would be. So making like a native application might not even like be in a situation like that. That might not even be high on the list of any that you're getting into some serious stuff there. So it's just not something you just don't see it that often anymore. So mostly everything's gone web, and Phaser was actually created. It's actually developed by one developer. He's been working on it for I think about 10 years now. But the most famous game, which actually became a huge game, it made the developer millions and millions of dollars. It was called Vampire Survivors. But it was originally made in Phaser, which can handle a lot, surprisingly. But there are some limitations because it is not only using JavaScript, but it's also using the DOM, right? And so that was never intended for like a game with a large scope. And the problem with Vampire Survivors is it's what's called like a roguelike or a bullet hell. So there are a lot of game objects on screen at any given time, and this is the challenge with normal games, not with our Match 3 game, but with actually technically it does happen in our Match 3 game, but as you know, games are processing their game logic every second. And so Match 3 games, it's not like super big deal because things are happening much slower. But in a game like Vampire Survivors, the players, like everything's it's moving all the time. So once they started really expanding and started getting popular, they had to switch to, I think they switched to Unity. I'm not too sure, but it was either Unity or Godot. But they had to switch to a game engine that was more optimized to handle things like that. So there are limitations on it, but I mean, if you're making something for a web app, it's probably something with a simple game loop. For instance, I made basically a Flappy Bird clone using Phaser. It was extremely easy, extremely fast, and lightweight. So I made that game for a client I had in another country, and they have older phones and much worse internet. So instead of using a game engine or trying to do a native application, like a lot of that stuff wasn't going to work. A lot of their phones, when it comes to the client, they weren't some of them don't even have room. They're using much older iPhones, and as you know, iPhones, Apple does a lot of planned obsolescence, so they would struggle to have room on their phone. to actually, if you're going to make a native application, it has to be downloaded on your phone. So these are still client side as well, but it's significantly less storage. And so that's where something like Phaser would come into play in a web application, because they can access it anywhere. It is downloaded on their client, but the actual amount of storage is tiny. I mean, it's super tiny. And I was able to get it up and running very fast and adapt it very fast. So if I were to make the only other way that would be faster would be to make like something extremely native for both iOS and Android. Like at a very like low level in terms of like how I would program it. I mean, that's just so much work. It would, it would take me like, easily 10 times as long than just using Phaser and making it a web application. So that was actually a real world example of what I had to do, and it was just Flappy Bird. Very addictive, simple gameplay loop. But yeah, Phaser is not a one size fits all, but that's what we use under the hood here. Now we've let the time run out here, so we'll go ahead and end the game. When you click on it, game's over, it takes you right back to the beginning. But there's my new high score right there. And so this is actually in our database. So this is pulling from our database. Next.js is server side first, so it uses SSR. And I'll show you right here. So we do have the leaderboard right here. So it just updated mine. This is Supabase, which is a Postgres. Uses a Postgres, and it's what's called backend as a service. So it's very popular. I use it, very widely used. I use it all the time. But that's pretty much all it's doing. So everything here is handling authorization, authentication. I have different tables, and that's pretty much how we're handling that. So it's doing SSR, or it's using SSR. So it actually is sending the client, in this case us, or this screen right here. It's actually sending us raw HTML. The only thing that isn't is the game itself. That has to be client side. Any game has to be. But everything else, like the leaderboard, it's actually pulling from. It's all happening server side, so basically on Supabase's servers, and then, or if we wanted to rent our own or build our own and run them locally, it would be everything would be happening server side. And it's actually sending out raw HTML, which is better for SEO, and also it's faster. It's lightning fast, so it makes it easier on the client, which is something I in my earlier example of in that country where their phones weren't that great. Like server side has to that's the only true solution. And that's why you see a lot of other countries that, are having a tough time catching up, because the devices they're using are older. The internet, the infrastructure is not as good as what we have here in America. And then also, like in America, a lot of there is a bit of a movement switching over to like offline first and SSR, but a lot of other places, it's not like really popular overall. It is becoming more popular, but it's not like the dominant architectural like choice. So that's how that works. We're hosting on Vercel, so nothing crazy. Here's the different deployments we've had. I ran into some hiccups earlier with some of the sound effects were causing problems, but yeah, pretty much straightforward. Vercel, which actually makes Next.js, so it makes it a lot easier for them. And that's how we're hosting it. So it's just a regular old Next.js, Phaser, using Vercel for hosting, and Supabase for the database management, and also RPC. So I don't know if any of you listening have ever used Supabase before, but they do have incredible like functions with like edge functions and with RPC functions as well. So I can keep a lot of the logic actually in the database, and even like I can have logic like Crohn's, for instance, running on like on Postgres. So it adds not only a layer of massive security, but also like incredible performance, which would be good for like hypothetically if you have like tons, thousands, hundreds of thousands of users, it's so much better. And then also we have the option for server side as well. So any of the actual files that are where our code is on, where our code base is for the mono repo, any of the files, we have the ability to use them for client side, or like for instance, all the files for the game are pretty much client side files. So in Next.js, you just type use client at the top of the file. That lets it know that this is gonna be client side. So that's where you would store like you need to have like user input, state management. Never store any actual critical information or information that you would need that's specific to the customer. So for instance, like if you needed a customer email, definitely that's server side. But that's the great thing about Next.js is it does server side by default, And you can also have logic when you just type use server at the top of your TypeScript file. It's pure server side. So all that's happening in the server, the client actually will never see that. It gets compiled into HTML, and that's what they see. And then this project wasn't complicated enough to require it, but normally in my other things I've done in my professional life, we use DTOs, or data transfer objects. So I can actually, what I can do is I can load in I can make one call to the database, right? I can pull any information that I need, and then it caches it, right? Because it's all happening server side, so the client will never see this. And then I use what's called the DTO, so I can only from there I have like let's just say I pulled every possible piece of data that we keep on a user profile, right? And I have it's cached, right? Or well, that's not cached, but it's I guess you can think of it as cached server side. And then we use a DTO, and we pick basically which data points. Maybe we just want the username and their score, right? Their high score, and that's the only thing that actually gets sent client side. And then client side, we can cache it, right? If we want, especially if we want to be offline first. I've made applications that are because there's this one country I was doing work for, and they get a lot of power outages and stuff like that. It's thunderstorms. There are a lot of power outages. Even power outages just for no reason. They're just their infrastructure is not good. So that was one where I had to do that. I had to basically figure out a way to store it. Keep everything light for their older phones. I had to keep everything as small as possible, but I would store it client side. And so every time they load the app, the first thing it does is it checks the cache first, right? And then once it checks the cache, and they have a reliable internet connection, it would check the database real quick, check the server side to see if it was there. And if there was any user input change, then it would send a post request, right, to the database. So obviously these things are way out of, they were way out of the scope of what we needed here. But it's just kind of an example of what Next.js can do. And if we were to continue to actually make this a real game that we're trying to, put into production to actually make some money, those are the things, those are the type of design decisions that me and Christine would further come up with. But that's pretty much how this app works. So Crimson Crush is just trying to display a little bit of everything in terms of, what you can do with an application. Christine handled all the design decisions. I can't say how impressed I was with her ability to she made a lot of assets. So she was really good at that, and she was super adaptable. So anytime we needed, typical right with any company where you got UI UX and development kind of going back and forth, but we worked really well together. She was able to fix things real quickly, so that's why it made it a lot easier for me, because I just had to get everything to stop being bugged. But that's pretty much wraps up this presentation. So I hope you enjoyed it, and by the time you're watching this, I hope you get to actually play the game yourself and enjoy it. And other than that, you have a great rest of your day. Take care.